Welcome to Scientific Software Horizons, the podcast where curious minds in science and technology come together to explore what's next for scientific software. Each episode brings you into the conversation with cross-disciplinary experts and community visionaries as we dig into the opportunities, challenges, breakthroughs, and emerging solutions shaping the future of scientific software. From HPC to AI to quantum, we're diving into the technical leaps and the human stories behind them, the people, the practices, and the evolving ecosystem driving tomorrow's discovery.
Well, hello and welcome to the introductory episode of Scientific Software Horizons. This is the perfect starting point for new listeners. I'm Mike Bernhardt, and I'll be your moderator for this episode, where we'll introduce the themes that are shaping our conversations, the communities we aim to serve, and why this moment calls for a deeper look at the rapidly evolving landscape of scientific software. And to keep the content as fresh as possible, we'll also touch on the many related connections, such as the U.S. Genesis mission evolution, scientific software in the news, and the future direction of scientific software ecosystems. So let's get started by introducing the collaborators behind Scientific Software Horizons. Michael Heroux and Lois Curfman McInnes, the former directors of the Software Technology Leadership Team of the U.S. Department of Energy's Exascale Computing Project. Lois and Mike are two of the most respected voices guiding the future of scientific software. Welcome, Lois. It's great to have you here today.
Thanks so much, Mike. I'm very excited to be here and to be launching this podcast with our team. I'm looking forward to talking about issues all across the spectrum. I'm especially interested in how new needs in science and also changes in infrastructure, particularly AI, are driving changes in scientific computing, including software, methodologies, workflows, and communities.
All right. And Mike, or should I say, Professor Heroux, a big welcome to you as well.
Thank you, Mike. Happy to be here. I'm excited to be part of this conversation. Don't really know where it's going to go. And I think that's part of why, in fact, the main reason why we need to have these conversations is I don't think anybody on the planet knows exactly where scientific software is going and what the horizon may contain.
Fantastic. Well, after many months of discussion and planning, here we are. It's been, more than a year since we wrapped up the Exascale Computing Project. So, Lois, would you give our listeners a recap of where you are and what you're doing these days?
Sure. I am currently a senior computational scientist at Argonne National Lab, working in the Mathematics and Computer Science Division. My work focuses on high-performance computational science with emphasis on scalable numerical libraries and community collaboration toward productive and sustainable scientific software ecosystems. I'll mention just one current project. I'm partnering with Mike Heroux to lead the PESO project, which is working in close collaboration with the Consortium for the Advancement of Scientific Software. And together we're working to coordinate stewardship, integration, and quality-focused activities across a diverse portfolio of software projects funded by the Department of Energy. In this work and in my other activities, I'm especially interested in how our community as a whole are adapting as we're all moving forward to tackle new science drivers through advanced computing. For example, as a community, we're incorporating new technologies such as increasingly heterogeneous computing architectures, AI tools, workflows, and new software methodologies, while we're also addressing issues in workforce development.
Keeping yourself busy, I can see that, Lois. Mike Heroux, what have you been up to?
Well, I have retired from Sandia about a little more than a year ago, but I'm still very engaged in the scientific software community. As Lois mentioned, we work together as cohort on the PESO project, and that's keeping us quite busy trying to figure out what the role of scientific libraries and tools will be as we go forward and provide those capabilities to the community. I'm also a visiting scholar at Hewlett-Packard Enterprise, helping them address some of the issues, the same kinds of issues from industry perspective. I still teach at St. John's University as a scientist in residence, working with students on the use of AI tools for scientific research. It's been a lot of fun, a very dynamic environment. And finally, I do a little bit of writing for Hyperion Research, trying to bring to light interesting topics that might be of interest to their customers.
Wow. As I'm listening to this, I know our listeners will benefit from the tremendous depth and breadth of experience that the two of you will bring to these discussions. Mike, would you be so kind as to kick this off? And my first question is, what is your goal for the Scientific Software Horizons podcast?
Yeah, that's a great question. I think primarily we want to get people talking. Many people have a partial sense of where the community is going when it comes to what the scientific software needs are and what capabilities could be developed to address those needs. But I don't know of anybody who has a comprehensive view. So we need to bring people together in conversation to make sure that we can get a lot of this kind of partial sense of what the future might be, what the horizons are, and get conversation going between them. I often think of this phrase that knowledge is developed on the edges, and that is in conversation between people who have a deep sense of what's possible and a deep sense of what's needed. And in conversation, we can identify capabilities that meet needs and do that iteratively so that we can continue to make progress.
I would add to Mike's comments to say that this is an especially interesting area because it is by nature so very interdisciplinary. We expect in the podcast to have dialogue involving people whose backgrounds span applied math, computer science, AI, various scientific domains, workforce development, community development, sociology, pedagogy, all sorts of areas that come together in important and interesting ways to help us as a community move forward to advance both scientific software and discovery.
Why now? Why launch this podcast in 2026?
2026 marks a pivotal transition period for our community, where scientific software is undergoing a generational shift. We know that AI is rapidly transforming everything we do, especially research workflows and scientific software. Consequently, how we do our science, which is typically interdisciplinary team science, is growing and changing. Working in cross-disciplinary teams is the norm for much of the science that we do. Consequently, thinking very carefully about how we design, develop, and encapsulate our expertise in software is quite important. Also, thinking about the human aspects of our work is more important than ever. Especially as we're seeing more use of AI in our community, we need to understand how interactions between humans and AI systems in science will continue to evolve and change. And during that time, we need to understand how to ensure trust, appropriate training, and to work to incorporate both social and technical factors in a co-design way to move forward.
I'd like to also mention some additional things like now, budgets, for example, are changing pretty dramatically. Funding profiles in general are changing. AI, quantum are in some ways maybe diverting from funds from HPC, but maybe diverting them from a much larger pot in which traditional modeling and simulation can still have a strong role. And in fact, I look at the emergence of what are so-called world models, which are gaining a lot of attention in industry right now. Those are based on the notion that we have a realistic understanding of how the world behaves. And guess what? Modeling and simulation can play a big role in developing high fidelity and trustworthy world models. And so there's a lot of opportunity, even with all of the uncertainty that's going on. And we need to get people together to have conversations and learn from each other what's possible.
The two of you have described a wide and I'd say a deep range of content to be discussed. So help us understand who is the target audience and who will benefit from this podcast.
I think many people can benefit and can contribute to this conversation. Certainly the scientific community, software and modeling and simulation, AI play a large role in gaining insight into scientific problems, coming up with new discoveries. And so anybody who's involved in the scientific enterprise is going to care. I would also say that people who are in the broader AI community, broader business community, could benefit from them. Because as I said, these so-called world models are going to be informed in part by the capabilities of modeling and simulation in a more classic sense that HPC has been a big enabler of. And so anybody who's interested in advancing the state of the art for AI engines will care about what we're talking about, at least tangentially.
I would say that our intent to engage such a broad spectrum of voices and backgrounds in podcast discussions enable us to work now during this inflection point when new practices and priorities in our community are still forming. So we're really aiming for podcast discussions to help inform, contextualize, and shape the emerging landscape in scientific computing.
I've been very fortunate to have worked with the two of you, with Mike and Lois, for years as part of the Exascale Computing Project. But not all of our listeners will be able to connect the dots from that massive effort to why this is such a perfect platform for reaching out to the scientific software community. Perhaps you could speak just a bit on that, on how your experience leading the software technology group of the Exascale Computing Project has influenced your decision to produce this podcast. Mike, would you like to start?
Yeah, sure, I can start. As you already mentioned to Mike Bernhardt, the podcast has emerged as a really important communication platform for getting ideas out and engaging the broader community. I have to say, I am not necessarily a podcast kind of person. I have to learn how to do this, and I hope that's okay. But I do think it's important. It's important enough that I'm going to try to get over my discomfort doing this because I think it is that important.
We found that during the Exascale Computing Project, our community had a really unique opportunity to dive in deeply and for a sustained range of time to have rich relationships across a broad collaborative space, including the developers of scientific libraries and tools, and also the creators of scientific applications. That is, people who are experts in computational chemistry, physics, biology, and so on. We found out through these interactions that we had very rich opportunities to advance our scientific discovery by building on advances in scientific software practices and team practices. So these community interactions and even new interactions that we're experiencing now after the Exascale Computing Project has concluded are inspiring us to move forward with this broader podcast environment to propel conversations forward, to not only help us do our work now, but to help us both grow and sustain the workforce that we need in order to move ahead as a community to advance new science drivers.
Both of you have laid out a strong justification in my mind for why anyone in the scientific software community will benefit from this podcast series. But what about guest commentators on the program? I know that that's going to be a big part of this, is that community voice. Could you share with our listeners who you have lined up for any of the future episodes?
Yeah, yes, we do plan to have a wide variety of guests. We have our first guest lined up. It's Professor Jack Dungara from the University of Tennessee at Knoxville. Jack is arguably the most widely recognized name throughout the world in scientific software, and he has maintained a deep interest in the evolution of scientific software, even in the presence of AI and quantum. And we look forward to him setting the stage for later conversations. And we will have other guests as well that we'll line up. But at this point, Jack is kicking us off.
I'm honored that the two of you are allowing me to introduce the title of the very first episode of Scientific Software Horizons. And that title is The Code Behind the Curtain, Short Stories of Software That Makes Science Happen. And as you mentioned, Mike, it will be Professor Jack Dungara who will be your guest commentator on that one. I think that's it for this introductory episode. I hope this gives some folks some encouragement to tune in and sign up. We'll be diving into technical discussions as we move forward, including considerations for next generation ecosystems, and we'll highlight some of the key points of technical progress and future challenges. So we'd like to encourage all the listeners to please tell your colleagues about the podcast, remind them to follow us on the LinkedIn page to get updates on future episodes, special programs, and other activities. With that, thank you, sincerely thank you to our host, Mike Heroux and Lois Curfman McInnes. Thanks to our producer, the amazing Justin Bro. And for Scientific Software Horizons, I'm Mike Bernhardt.